interested in blockchain development, right? That's why you're here today. And many of you are brand new to blockchain. So what is blockchain probably is the first question you might have. And one question I had when I first started learning blockchain was, what kind of solutions can I build with blockchain? What's a good example app that might utilize a blockchain type scenario? And how do I get started? Always a big question, as well as layer one, layer two, all that kind of stuff. What's in layer one? You may have heard of the layers before with blockchain. And what does a blockchain solution look like? What are the moving parts of a blockchain solution? And then code, right? Show me the code. So we got a lot of code for our developer audience here today, as well as some tools that do not involve code, but are very useful as well. Show me the tool. So this is the agenda for the rest of the evening here. We got blockchain use cases. We'll start out answering the question of what could I use it for? And then what is blockchain? So we got blockchain basics for all the new folks out there. There are many of you in that category. And that'll be a quick overview for some of the experienced folks here too as well. Also layer one features, what is included there, and the tools, the developer tools, and lots of code. All right, so the first example here is Props Network. So this turns app users into loyal financial stakeholders. Props platform attracts blockchain technological complexity for apps. So basically they have widgets and SDKs that are available and APIs that can revolve around loyalty programs if you want to incorporate those into your apps or to your web applications. SEC approved token, and it's an ecosystem for token holders. So very cool, a good video on that on YouTube, as well as a use case right up on the Algorand site. This one here I'm pretty excited about. This is very recent, within the last couple of weeks. The Italian Society of Authors and Publishers had a great idea, which was to use digital copyrights on blockchain. And this is done via non-fungible tokens. And over 4 million of these NFTs are pushed onto Algorand for 95,000 plus creators. Now, an NFT is basically a token that's unique. And so each copyright is unique. And so for the first time now, copyrights are being represented as digital assets. Decentralized and transparent. Those are two big themes in a public blockchain. Also, it's global and open infrastructure and provides end-to-end protections. Doesn't matter what country you're in, it's global, right? So there's no boundaries here. And so this provides proof, right, of your copyright. And it really is the future of this entire industry on copyrights. And then also, I watched Saturday Night Live a couple of weeks ago, and they actually had a skit on there about blockchain and specifically NFTs. So I think you've hit the mainstream when you see a skit about a particular technology or whatever the case on Saturday Night Live. So that was entertaining. So I'd encourage you to look that up. That was a recent episode a couple of weeks ago. All right, Circle and Coinbase, the Centric Consortium. A very big application here. Payments and treasury infrastructure on the internet. You can accept payments, send out payments globally, leverage traditional payments like through credit cards, that sort of thing, but also through blockchain infrastructure. And global, scalable, efficient. And USDC is something you may have heard of. For those that haven't, it's a stable coin. And one of the problems with cryptocurrency of any sort, whether it's Bitcoin or Ethereum or Algorand's native currency, the algo, is there tends to be a lot of fluctuation. And that makes it very difficult in trading scenarios where maybe you are buying it at a very high rate, then all of a sudden it goes down. Now you're trying to sell it and you're losing money, that sort of thing. So that is a tough one. And so what has evolved now is a crypto coin that is tied to a fiat economy somewhere. The USDC is tied to the US economy. So it's a lot smoother in terms of the fluctuations. Fluctuates with the economy instead of the real big fluctuations you have typically with a native cryptocurrency. So that really has been welcomed with open arms. Now you can start doing transactions on the internet with the same kind of thought process in mind that you have doing regular USD transactions. And there's a good number in circulation, 2.3 billion in circulation. Again, another great use case. You can take a look at that up on our use cases site on Algorand. So it's not limited to money and cryptocurrencies and things like that. There's a lot of other use cases, right? We saw one up front on the copyrights, as well as now tamper-proof charity organizations. And these examples were taken from a recent China blockchain report for 2020. And then what you're seeing here is the China ministry is now using blockchain to improve transparency of social services. And the big thing is the ability to track all of the donations with an automatic audit trail that's built right into blockchain. So you see, they had problems before with this. They had, I think it was an earthquake about 10 years ago, and they lost track of where some of the funds are coming from and going to. So that was a real big problem. Not the case with the blockchain solution. It's an immutable ledger. It's very easy to detect tampering that may have taken place in the blockchain. Very easy to detect that. So it really is tamper-proof, and it's a read-only ledger with the right ones for the new transactions that are being written out to the blockchain. We'll take a little bit more of a detailed look at that in a minute. So voting, another example, tamper-proof voting, right? There's no ifs, ands, or buts about it. Once it's written to the blockchain, that really utilizes the protocol on the blockchain to avoid things like double spending, or in this case, it would be double voting, or things like not being able to prove that the vote came through. There's proof associated with each one of the votes. So very good application. Healthcare, another big area as well. It's really becoming very noticeable that the need is there for medical teams to have information on site at the site of the care. Now, this could be an emergency case. It could be maybe a new doctor you're going to in a new doctor's office. The days of spending a half hour to fill out all of your medical information hopefully are coming to an end once we have a lot of this accessible, for example, on a blockchain somewhere. And you would be in control of that, which is a very important thing, to be in control of your own information and not have a clearinghouse call you in a transaction process saying, we think there's been a breach and we need to give you a new card, that sort of thing. The transactions on blockchain are typically between sender and receiver, and that's it. There's no middleman. So that makes it a lot easier and a lot simpler. In the automotive industry, another great example, supply chain visibility with vehicle integrity. What they're doing, they're actually putting sensors into the engines to track wear and tear on the vehicle when spare parts were installed, that sort of thing. So now the whole used car industry is becoming a lot more stable in China as a result of using this particular approach. So hopefully I gave you some ideas, but by far the biggest area on blockchain, as far as applications go, is in DeFi. And let me tell you, this is just mind-blowing how exploding this is. Over $1 trillion in cumulative blockchain network value on last year, in 2020. In 2021, it's going to continue growing to $3 trillion, our forecast in the blockchain industry. There's a good overall report there at Massaria.io at the bottom of the deck. We will have a link to the deck at the end of the session, so you'll have all this information available to your fingertips. Algorand DeFi examples include IDEX, Monerium, Polkadot, stable coins like we had talked about with USDC and Tether and Meld and a few others. And so those are all written up on our use case site, as well as many other ones that you see listed here. The asset block is tokenizing real estate assets, for example. So you can have multiple owners on a hotel, and you divide up the assets accordingly through tokens. And a lot of other information here in terms of some of the quotes from the big players here. Chairman of the Circle, upper right there. The transaction fees are less than a penny. And there's nothing else that touches that in the blockchain space. Ethereum is several dollars, in the 20s, I think, dollars. And then also the speed is there too. With the Algorand blockchain, new blocks are created in under 5 seconds, as opposed to older blockchains like Bitcoin could take 10 to 15 minutes to burn a block. So Algorand blockchain lends itself to like point of sale transactions and things of that nature. And most of these comments are around performance and capabilities. We've got some good kudos there from Manny on the doc on the dev portal. And so you can read those at your leisure. The ecosystem has been a couple of years now over several technical companies and financial companies and applications that are evolving around the Algorand blockchain. One of three that have the top two stablecoins in USDC and USDT. So a lot of good things there happening, a lot of good synergy. So how about what is blockchain and the basics? So that's what this section is about. So I came up with this diagram on the blockchain. It's basically an immutable distributed ledger is the way you could think of it, with a handful of record types. First record type is a block. And a block is really just a point in time. And so a new one of these gets burned every 5 seconds or under. And then also associated with blocks are the transactions that occur during that time interval. And a transaction would have information about sending and receiving accounts. And then, so you have accounts that are related to transactions. And then each account can have one or more assets or one or more applications. And applications are smart contracts, and assets are your tokens that you can create to your own device. So very customizable, in other words, in terms of that. That's the lay of the land. So it is really straightforward when you think about it. It's not terribly complex, just a handful of record types. For those that are brand new to blockchain, how are the blocks built? So you've got a lot of blocks that are in a chain, one after the other. And some of you may have heard of forks or proof of work. We don't do either of those. Proof of work is not green whatsoever. There's a lot of computing power that's needed to generate a block. It's a tough math equation that is challenging to miners to try to solve. And as a result of that process, sometimes forks are created and then forks are orphaned. And it's very time consuming and not too efficient. Instead, what we see here is we're using simple math in the way of a verifiable random function, and with the Byzantine generals problem to kind of highlight what this is all about. So back in the day, the Byzantine Empire had a bunch of generals that needed to communicate before they planned an attack. And messengers are sent around, and if all the messengers make it, fine, everybody communicated fine, they're all on the same page. However, if a messenger misses, maybe got bad directions or had weather or got corrupted or broke a leg or whatever and didn't make it, then not all of the generals are accounted for in the decision-making process. And then there's scalabilities with this, issues with this as well. A lot of times you have a quadratic effect on cost versus number of folks that are in this agreement process. So if you get to maybe 10 generals, you get 10 squared in the cost. But if you get to 1 million generals, then you got like 1 million squared in the cost. And that's just phenomenal. So our founder, Silvio Macaulay, Turing Award winner, figured it out. You really don't need everyone to participate in the consensus, right? What you need is a representative sample. And that's where the VRF comes in, the verifiable random function. And all this is open sourced, by the way. So the verifiable random function is open source. Our blockchain is open sourced as well. And lastly, get to this section here on permission versus permissionless and public versus private. Again, I heard a lot of this when I first was learning chain. What kind of solutions can I build in each of these? And let's get the terminology down so we're all on the same level here. On a public blockchain, anyone can join and read and write the blockchain or the network. It's decentralized. No one has control over the network. It's secure and data cannot be changed once it is validated, like we talked about. On the other hand, a private blockchain is also referred to as a permissioned blockchain. And this restricts folks who are allowed to participate in the network. This is allowed in select transactions, or authentication is required for sure. And that's all done right on the blockchain as part of that scenario. What kind of apps can you build on these? Well, in the public and open, that makes the most sense, right? Now you got things like currencies are good for that, betting, video games. Really, information is not really critical in terms of privacy. And then you look at things like public and closed in the upper left. That's a voting scenario, perhaps, where it's got to be public, but you want it to be closed until maybe all the voting happens or something like that. And then private and open and the bottom, very good for supply chain type scenarios where you have several checkoffs along the way, corporate earnings statements, that sort of thing. And then the most private, as the bottom left, private and closed with construction, national defense, law enforcement, military. You can actually create any of these with a modern day blockchain and Algorand, and really what is, it's up to you and your developers to provide the authentication services into the blockchain. Again, that would be like a layer 2 or off the blockchain type scenario that would control the access to that particular set of data. So that is the bottom line. So really all of these types of applications can be built with Ethereum or with Algorand or Bitcoin. It's really the idea is behind it is the fact that it is at the base of it's public and open, and then you apply the authentication on top of that. And to be clear here, what our protocol is called at Algorand is the pure proof of stake protocol. True scalability, 1,000 transactions per second, and that's going up. Under 5-second block times, and that's going down. You got a lot of infrastructure longevity with all of the open sourced items and continuing ingenuity and updates. Technical flexibility, lots of SDKs, and transaction certainty, very important. When you do a transaction, you want to make sure this thing is actually firing off. Platform extensibility with very energy efficient. It's pretty lean and mean. You can run a node on a Raspberry Pi. Extremely cost efficient, under a penny a transaction, and then also provides true security in the way that a blockchain would. A great video. I'll leave this as a homework assignment to watch on the protocol itself, but really the best thing is yet to come here in the session. That's revolving around layer 1 features and then the code we want to look at. So layer 1 versus layer 2. Layer 1, you can consider that features that are built into the blockchain itself. And then layer 2 would be solutions that are built on top of the blockchain. Typically, layer 2 solutions might be built with one of the SDKs, for example, Python SDK specifically for this group. Layer 1 features built into the blockchain itself. That's what this section's about. And we'll go over the different features that we have on layer 1. But the idea here is scale is needed for a global blockchain. So you really want to try to keep layer 1 lean and mean, because putting things like VMs on the blockchain, like some other blockchains have tried in the past, just doesn't work. It's too resource intensive. And you really want things to be very lean and mean and quick and performant on a blockchain. So we've learned a lot as time has gone on. If you look at the technology that was around over 10 years ago when Bitcoin came out versus the technology in general, now there's a huge difference. And the same goes with blockchains as well. And a lot of people are figuring this out. Algorand layer 1 features include standard assets. Those are the tokens we've been talking about. So you can do that natively right on the blockchain. Atomic transactions is huge. This is could be the secret sauce of architecting a solution, tying together many related transactions into one big one. Algorand smart contracts provides a logic capability to do signing and transactions, as well as a feature called rekeying to rekey the secret keys. So I'm going to explain a lot of this in this section here. So bringing back our diagram, where does this fit into our distributed ledger? Where really the atomic transactions wrap around transactions. And then rekeying is associated with accounts. And then the smart contracts are your applications, and ASAs are assets that are associated with the accounts. So diving into ASA, these create native tokens. So you have the same functions as the base blockchain, like eliminating double spending or having insufficient funds, that sort of thing. Also provides asset spam protection, resides on layer 1. This is where we get into 2 types of assets: fungible tokens. So this would be like stable coins, loyalty points, system credits, that sort of thing, cryptocurrencies. And then the restricted might be things you could do clawbacks on. And then you get into the NFTs on the right side. Could be unique in-game items, supply chain, real estate, identity. These are all there: real estate, ownership, registry, and certifications. So let's take a look at creating some tokens. This is an online tool called AlgoDesk, and we're just going to dive into the asset manager. There's also other pieces to this in terms of the application manager, web wallet, and the contract builder. For now, we'll go into the asset manager. So here is a unique identifier account mnemonic. So that's your private key. You never want to share that with anybody. And this will get started. So we're going to use that one that's there. You could paste in yours too if you already have an account, you got your secret key. Let's go ahead and create an asset. So with the asset, we're going to call this thing Pizza Russ, P Russ for the unit name, which is the 8 characters are under. Total supply, let's go with 10,000 of these. We'll do a decimal of 1. So now that's 10,000.1 units. Also, there is the ability to put a URL that's associated with the asset. You can also have a metadata hash there. So if you're storing things on like a distributed storage system like IPFS, you can do a meta hash of that particular asset and provide a nice information about that particular asset. Also, you can see our management functions here on the bottom. You got a manager address, a freeze address, someone that's in charge of reserve, someone that's in charge of clawbacks. So initially, these are all set to the creator account. Well, let's go ahead and create this. So now it's waiting for the transaction to confirm, which is that basically while the block is being built. And then now you can see going right down to the bottom here, that new Pizza Russ that got created. There are several things you can do at this point. You can send this asset to someone who's opted in. You can modify the asset. You can freeze it, unfreeze it, revoke it, delete it. Or let's go ahead and just look at this in one of our browsers. So this is going to bring up an Algo Explorer, again, a community browser. And you can see all the details about this. There is the information on this particular, I picked in the Shady Club by mistake. I was looking at the wrong asset. Must have flipped off the screen there for a second. Let's bring up the one that I did. Right down over here at the bottom. There we go. This one here will be better. There we go. Yeah, because now we got total supply like we entered was 10,000. There's unit name P Russ. So the thing that's unique about this, though, is the ID. You can have the same unit name. You can have the same general name for an asset. But the one thing that is unique is the ID number. So if you are ever getting an asset or receiving an asset from somebody, typically they'll tell you what the ID number is, and then you'll see that in your wallet. You can go ahead and opt in to transact on that. Or if you're writing a game, you can opt in to receive those game tokens with that particular ID. All right, so that's a lot of great information. Also, you can drill through and you can see the transaction information here, as well as the creator account, the freeze account, and everything that was used to build this particular transaction. And going back out to the deck, there's another Explorer as well called Gold Seeker. And Algo Signer is like a MetaMask equivalent for those that are familiar with using MetaMask for Ethereum. But basically, it's a wallet that you have available to you here. All right, so I'll log in here and I'll show you this here in the upper right corner. All right, so we've got an account I want to transfer some funds to. So I'm going to go ahead and copy one of these off that I have. And I'm going to say, okay, let's go ahead. And I want to get out on testnet. And there is these are all testnet algos that are in here. So I've got my pizza demo. I'm going to go ahead and send some assets. Let's go to this particular address. And the note field is free form. You could put any structure you want in there. I'm just going to use text. And what would be a developer session without a hello world example, right? So I'm going to go ahead and then send this off, and we're going to put an amount to it. I'm going to send 1 algo out. So let's go ahead and send this. And once the transaction completes, you'll see the transaction ID. I can actually copy that off, go back to the account. Now I can go to that, maybe that other Explorer that we have here with the Goal Seeker, just so you can see a little bit of a difference. And I could do a paste here and paste in that transaction. And now you can see the sender, the receiver that I pasted in, the amount is 1 algo. And then the note that we have in there was plain text, so that comes out. And there you go. And there's our average block time per second on testnet and average reward rate. So a lot of great stuff there. And all of these have a drop down for mainnet or testnet. So you can do a search there as well. and paste in that information. You can see it right there that we did it. Okay, Algorand atomic transfers almost succeed or fail. So those that have a SQL database background, that's exactly like a transaction in a SQL database is what we're talking about. And this is an on-chain native function, as all of these layer ones functions are. It's easy and secure. You can do up to 16 transactions in an atomic transfer. And what this does is it guarantees an exchange of goods. So if you look at the diagram at the right, an atomic transfer example might be person A is going to spend 50 algos and person B is going to receive it in exchange for person B sending a concert ticket to person A. So if person A sends a 50 algos to person B, but they don't send the concert ticket back, everything's null and void. It's like the person A never sent the 50 algos. And then you can put time parameters within a certain amount of time, that sort of thing. But the idea is very simple there, and that's it. And this is really good because now you can start combining with other Algorand technologies. Like you could combine an atomic transfer with the smart contract. Maybe the smart contract piece has the time limit on it. It has to occur within a certain amount of time. And so things are really starting to evolve here into what we refer to as like a solution, solution for a blockchain use case. And then the atomic examples of atomic transfers might be things like multilateral trades, circular trades, group payments, combining with smart contracts and NASA, also instant settlement for complex multi-party asset transactions. Distributed payments are all part of the mix there. And then we get into smart contracts. You get the TEAL, transaction execution approval language. This is an assembler-like language, stack-based, non-Turing complete, and it is very fast. So that's what we were talking about on the blockchain, is something that's got to be lickety-split fast and yet provides the ability to do logic, hence TEAL. Also, there is a Python-enabled compiler, so y'all be very happy about that. So you don't actually have to generate the assembler code natively. You can do it in Python, and then there's a compiler method to compile that Python code into TEAL. Also, two types of smart contracts. You've got stateless, you've got approval spending transactions, and stateful, which would provide the ability to store information on globally on the blockchain or at the account level on local storage. Combinable with other Algorand technologies, with atomic transfers, Algorand assets, and also you combine stateless with stateful contracts. Stateless, by the way, the contract comes back either true or false. It comes back true, it goes ahead and signs it, and it's on its way. So that's a very simple process there. And also a little bit more on stateless smart contracts. So you got two types. You got a logic account and a logic signature. So logic account is basically the true or false only kind of scenario I just talked about. Good for escrow style accounts, split payments, hash time lock contracts. Then also there's one, if you want a little bit more of a delegated authority in addition to the logic, in other words, an account has to also sign off on it, that would be a logic signature. So an example of that might be recurring payments. And I'll show you a demo of that in a second. And then also we got stateful smart contract life cycles, the ability to create an application, opt-in. No op is the same as calling the app. There's an ability to update an application. You have the ability to delete an application, close it out, as well as clear state, which will always clear. Close out will only, the TEAL logic must be true to close it out. And more information on our developer portal with the link there. Now, a little bit about Algorand accounts. There's three different types. You got a standard account, a multi-sig account, and then a logic account. And so multi-sig is basically a threshold you would set out of a group of accounts. Let's say you got 10 accounts and you want to set a threshold of 5. So at least half of the members of that group have to sign off on a transaction. And if that threshold is reached, all is good, and it's going to fire off that particular transaction. So that might be good in an example of a board of directors scenario. A logic account, again, returns true or false, whether to sign it or not. And then they have the individual account. Now, each of these have a public and private key. Now, the private key is the one you want to keep secret. This is also referred to as a secret key. You never ever want to give that to anybody. Versus the public key, yeah, you want to give that one out because that's how you're going to get money, right? That's how you're going to get assets, is for people to send it to you on that particular public key. Private keys can be maintained in a wallet. It is a cryptographic key pair between the two. The problem was, when you say evolve, you start out maybe as a single account. Then maybe you get that board of directors scenario where you want a multi-sig account. Up until recently, you've had to recreate both of these from scratch and then transfer everything over. And it was very cumbersome to do that. We're, I think, one of the few blockchains, if not the only blockchain, that makes this very easy to do by simply rekeying it. And you can see with the transaction, it looks here on the right, that we have a rekeyed account. So this address that begins with L42 has an authorized address now of NFF. So NFF is actually going to be the spending key or the signing key that would be associated with that particular transaction. So pretty smart, very easy to implement, and really provides you a lot of flexibility. That brings us to the wallet. You can download the wallet, the Algorand Wallet, from the App Store and Google Play. You got NanoX ledger support, testnet, mainnet settings, rekey to the ledger with asset support as well. So the important one out of those I like is the testnet mainnet settings. So if you're doing some testing, you can see very easily in your wallet the results. It happens 5 seconds later, then boom, you got it inside of your wallet. Smart contract value, then basically the financial industry, lots of them, like the examples would be trade finance, clearing and settlement, financial data recording, digital identity. And then in the DeFi space, you got escrow, payments, credit lending, and stable coins. That brings us to Indexer. How do you get data off the blockchain? Well, you could query it natively through the AlgoD process. That's one of the daemons. And you would be able to get information that resides directly on the blockchain. However, lots of times you may have a need for something that might be a complex query, or one that you want to happen lickety split really quick and not wait for the time for it to traverse a million blocks that are chained one at a time together. Enter Indexer. Indexer is a process that will basically feed off of AlgoD and then write the information out to a PostgreSQL database. And then you can do reporting or do your queries against that PostgreSQL database. These are accessible from all the SDKs, including Python, JavaScript, Java, and Go. And then you can see you've got the ability to use the Sandbox as a default. We'll talk about the Sandbox in a minute, but basically that's a Docker instance that you would have on any of the platforms that you can utilize. That's the quickest way to get up and running. So the default, if you just say Sandbox up, that'll go to the private network, and the private network then is built from the Genesis block, and so the indexer could easily run alongside of that. If you have needs for this in testnet or in mainnet, basically the Pure Stake and Rand Labs provide a stand-up instance that you can access, or you can build your own. I have my own running here on my machine. It does take quite a bit of space, maybe 100 gig, I think was the last thing I saw. Those are basically your basic choices for that. And then we get into voting, which was one of the examples I want to cover here for a solution. And these are all tied together atomically, like we had talked about. So you have a voting commission, for example, and issues a spend voting token. And then there's some logic that's applied. Once this vote is cast for candidate A, then there might be some smart contract logic that might be utilized to validate that particular candidate vote. And if it passes, then you increment the candidate A vote to the total in global state. So this would be a stateful smart contract that would do that. Another example is crowdfunding, right? A very big solution nowadays. And this is typically how it's done behind the scenes, is through blockchain. So an example might be you come up with a unique chess set. You want to sell it. You have a certain threshold you want to raise in the escrow account funds. Otherwise, if you don't raise that amount, everybody will get their money back, right? That they've pledged. So basically, that's the scenario. And you take maybe a stateless smart contract to do some of that logic work up front, and you get the payment from the escrow to user one. And then the user then claims the escrow funds, right? Who's ever doing that. And then you might have a smart contract that is a stateful smart contract involved there to actually complete this whole process. So once again, here we're combining stateless with stateful, all atomically grouped. Tools, baby. Let's get to the tools. So we got a great developer portal. We recently won an award on that, Devi's Award from the Best in Innovation Blockchain category for the developer portal. So I hope you enjoy it. If you want to get started, just go out to developer.algorand.org and click on the Start Building button you see here on the right. And then these are the first 4 steps you would do. You'd set up your workspace, connect to a node, do your first transaction, and take a look at some smart contract stuff in building applications. Lots of tutorials, lots of solutions, lots of articles. Those tutorials are step-by-step out there. This is the lay of the land. You heard me mention a few of these, but basically you get BetaNet is the version that's used for the newest protocol level features. You got testnet and mainnet, which are always mirrored. The idea there is if it works in testnet, it'll work in mainnet. And then also you have private networks you can utilize, which I had mentioned with the Sandbox uses that by default. And so typically that's used for playgrounds. I like to use that to do a snapshot of BetaNet. Sometimes when I am doing testing on BetaNet features, because the BetaNet is very volatile, it'll change often. So if I want to get some stable testing on a new feature, I'll go ahead and use that for private networks there. So private networks is like a personal network. It resides on your machine. That's the best way I can describe that. And then nodes, you can build your own. You do it on Windows now too, as well as Linux and Ubuntu and Mac. And then also PureStake and RAN Labs have fully indexed, fully archived nodes that you can access from SDK code and on platforms that do not have nodes, like a mobile device, for example. If you wanted to invoke a call to the Algorand blockchain, you can do that by talking to one of these stand-up services. And then you got Sandbox is a Docker instance, not typically for production. It takes a snapshot from the current node and does a fast catch up, and there's no sync time. And Sandbox is simple. Just clone the GitHub repository under Algorand for Sandbox, install Docker, and you're up and running. So defaults to the private network and just do Sandbox up. If you want to utilize testnet, it'll be Sandbox up testnet. Now you get into some of the information you need when you're doing programming, and that is like the address and the token you would need. You can see those specified here. The address for AlgoD is 4001, and then the token is all A's. There's also an indexer URL, and then KMD is like an online wallet capabilities. Not too much of a use for that, but it's there if you need to do that type of testing. So lots of code tools, lots of SDKs, lots of languages. Let's talk about some of these. So everything you're seeing highlighted in red is done by Algorand, and the rest is through a thriving developer community. It has really taken off. You can see all the IDEs on the right. That the one I'll show you pretty soon will be the AlgoDia, bottom right corner. That'll be your second download after you get Sandbox done. That one there is highly productive. Also, you've got managing some of your solutions you're building with Algorand Studio and Algo Builder. And I showed you Algodesk IO. On the left side, we've got Java, JavaScript, Go, and Python. And then also you got Teal and PyTeal for some of the languages. And then you also got Rust, PHP, Dart, and C# SDKs that the community has done. So let's take a look at creating accounts. I'm going to bring up VS Code here, and I'm just going to hit run here in Python, and you'll see the results print out toward the bottom here. There it goes. All right. So now if you look down below, information has been written out to the terminal with some addresses. And then these are the mnemonics that got created. And the code that did that is very simple. There's a mnemonic you take from private key, and then that ends up being the mnemonic that I'm printing out down below. The generate account method is how you create a brand new account, and pretty straightforward, very simple there in terms of doing that. The one thing you do need to do is, this is a test net. Actually, this account could be used in any of the networks. The one that typically developers will use will be testnet. So what you need to do is go to the dispenser and dispense some funds in it. You will need funds to cover transaction costs, and these are free, right, for the purposes of testnet. And there you can see now it's been a success. So if I was to take this account, go look at and explore, you'd see I have some algo sitting in that particular account. So that's the second thing that you would need to do. And once again, I'm just going to hit run. I've got the breakpoint set here. And what you'll see here is now I'm going to restore using that passphrase an account. This is for demo purposes only. You never ever really want to put this in a production code, a secret key. You would rather in production, you interact with either that algo signer has an API you can interface with, the MyAlgo is another tool, or the Algorand Wallet. These are all possibilities that you can use for your key management. And there is in this case, I'm using the PureStake node commented out. I've got the Sandbox code, right? If I was using the Sandbox, I'd use this 401 and port number, a local host, and then that token. So now continuing on, the next set here, I'm going to encode a note in the note field, just a hello code. I've got a receiver set who's going to receive the transaction. This is a parameters that are built in as a call. You can see the params are as a parameter to the call for the payment transaction. So it's going to go from my address. This is the one that's we had to get the private key for up here, because that is going to be the one that's sending the money or signing it. And then you have the amount. Now this is in micro algos. So that's actually one algo we're going to be sending on this transaction. And there you can see the note field that is listed there. So now I'm going to go ahead and take that. Now I've got the signed transaction, and this send transaction is going to broadcast it to the blockchain. I'm just going to hit go here, and then it's going to go through this wait for confirmation method down here, and it will go ahead and dispense the funds to that particular transaction. You can see it was successful, and there's the amount, and there's the to address, and everything else is fine. And there's the decoded note. Once we get done at the bottom, we take a look at that and decode that note field. So that's a very quick demo on like getting started and some of your basic stuff. The other thing I want to show you here now is Algodia. All right, first of all, on the right, this is you set up which nodes you want to access. So is it a local node? Is it a PureStake? There's also a hackathon instance we have available for those that are doing hackathons. Let us know. We'll give you the information for that. Also, mainnet so it's nice to be able to easily switch these between, because it beats having to make code changes. You just do it here. And this is all visual, what I'm going to show you here. Basically, what we got now is the ability to perform all these type of things. Like you can create a new account. Let's do that, actually. Let's do one right now. And let's say test account, and then hit OK. And that's how easy it was. So this is the equivalent of what I just showed you in code. And there's the mnemonic, and then here's the new address. And then again, you'd have to do the same thing here. You have to go out and populate that with the dispenser for testnet usage. Also, it slices, it dices. You can create assets, right? You can come down here, you can create an asset like we did visually as well with Algodesk, but you can do it right here as part of the IDE. You've got stateful and stateless smart contract support. You can compile PYTEAL right in here. You can do transfers and atomic transfers. Let me show you an example of one of these. I'm going to go and do a stateless smart contract. So this is going to generate a logic sig. I'm going to do the delegated signature flavor. So this contract has to return true. And what's behind us here is basically you've got a receiver, and the receiver's got to match up with Bob's address, which begins with WCM. And the amount has to be at least one algo. And so that's what we're setting up. And if that returns true, that's going to work. So I'm going to use Alice is going to be the sender on this account. And I'm just going to hit OK. And now that generated the LSIG up here in the IDE. So now what I can do is I can do a send transaction. So the stateless smart contract is going to send it from Alice's address. And let's put in maybe this new test account we just created. Now this is going to fail, right? Because it doesn't match Bob. So that's what we're expecting. And sure enough, you get all this red that it failed and that it's not available. It's not working. So instead, let's do this so that we will go ahead and do a transaction. Now we're going to send it again, or attempt to send it again, but this time we're going to pick the right address. We're going to pick Bob's address. It begins with that WCM. That's what the teal is testing for. Now I'm going to hit OK, and boom, now it's successfully signed and sent that out. That's a great example. I find this extremely productive, right, to utilize. Okay, next one is our NFTs that we talked about. Well, how do I build NFTs? Well, one way of doing it is, like we alluded to, is just create an asset, an ASA, and give it a quantity of 1. You can also do NFTs with unique transfer logic, can be built using stateful smart contracts. Also, NFTs can be built using ASAs, can be manipulated with unique logic using stateless smart contracts. And then you can have highly configurable NFT applications can be built using a combination of atomic transfers, ASA, stateful, and smart contracts as well. And then let's take a look at this demo here to go ahead and mint one of these. So I'm going to go ahead and bring this up. I'm going to do a new NFT. And if you read that through, it's going to say, I am going to create an NFT. And what I want to use it for is basically, I want to use this for going and creating a photo or a video, you can just, or any audio type or anything of any other digital file. So I'm going to go ahead and paste in a URL. And then I'm going to go ahead and call this thing Russ Mario. And go next, paste this in. And then now this is the image. It's a pretty cool image, right? I'm going to be pasting in, and then now it's going to mint that asset. And then you can actually go out and see the minting of this and information on any of the blockchain explorers. And there is the creation. Now it's actually been successfully added, and you go to view this in the Explorer. And then you can see this last transaction we just did 19 seconds ago. That was basically it that you see for this particular account. And if you drill in on the transaction ID, now you can see there's the creator account. That's the manager account. And look, this is how the note field is used by a structure, right? So it's got the minted by field. This is all custom fields, right, for this website that's utilizing it, what type it is, it's an image, and then the URL is specified in there. So programmatically, you can access this note field and then say, okay, I know where this is. I'm going to go ahead and display this based on that particular field. So that's a very quick example of doing some minting on NFTs. There is also Unity 3D SDK. Let me show you this real quick. So if you're anybody building games out there, I did a proof of concept here on this one. So what I'm going to do here is let me go ahead and just attach this to Unity. And then I'm going to hit run here. And this is the player is the cylinder that you see here. And what we want to do is crash into one of these coins. So that'll be a collision event. And I capture that in the code. And we're going to then execute this player with Algorand function. And we're going to do 2 things. First is we're going to do a transaction. So here is the source account, destination account. I'm going to do a regular transaction. I got a method for that. And I'm going to do an ASA transaction. So the first one I do is going to be a regular transaction. And this is going to get payment information here. Come back. And they succeeded. You should see a message appear down here shortly that the transaction occurred. Now I'm going to do the ASA. The ASA is a game token, right? So if you collect game tokens when you gobble up those coins, and that's exactly what's happening here. And this is a transaction call for assets. So I'm going to transfer an asset from the game account, the developer account, right, to the player account, which is going to be the destination address. This is the asset ID that's we've established for the game token. And we're going to send one of those tokens, and then that's it. And now you've got the ability to do tokens inside of games with that particular SDK. All right. Continuing on, and you could, copy and paste that ID, go out to the Explorer, and you can see the information on that as well. All right. All right, multi-sig and atomic. So this is pretty important. Let me go ahead and bring that up in the code. Back to the code. And let's do the multi-sig first. And let's fire it up. So what multi-sig is about, again, it's a multi-signature, right? You need to set a threshold of how many folks are going to be signing off on this. And what you want to do then is create a multi-sig transaction based on that. And so what we see here is we've got a multi-sig account that we created up above here with a threshold of 2. And we actually only put 2 accounts in. So both of them need to assign. You can have multiple accounts here in this array. And once that's done, then you come up with an address that's associated with that. And we printed that off down below here. And this address is what you would need to have funded to be able to send, because that's the one that's going to be sending the funds out, is the multi-sig address. And this address will always be the same if you use the same threshold number, the same version number, and the order of the accounts are the same. So that's consistent. And then we've got the parms we're going to get like we've done before. The new part to this is basically combining those particular transactions. And we do that right down here. You got 2 signers, right? Private key 1 and private key 2 are going to be signing this off. And then we want to do is combine both of those into a multi-sig transaction, which you see right here. The multi-sig transaction is what we're going to be sending as part of our raw transaction. And then we're going to wait for that confirmation to come back as well. So I'm just going to let this run. And now this is going to step over that and go down and print the confirmation down below that it was indeed successful. And so that's what's behind a multi-signature transaction. And the other one I want to show you here is the one that revolves around atomic transfers. And so what I'm going to do here is run this. And the atomic transfer, once again, groups together transactions, and both have to work or neither of them will work. The 2 transactions we're going to wrap in this example is we're going to send an amount of 1 algo from account 1 to account 3. And then we're going to send from account 2 to account 1, 2 algos. So those are TX1 and TX2 right there. And now I'm just going to hit the run button here, and let's actually combine these down in the group ID. So the group ID is going to say, okay, these are all part of the same thing. And then we're going to go ahead then and do our signing on each one of these transactions with the respective keys. And lastly, we'll append both of these into a signed group. And that's what we're going to be broadcasting, is the signed group. Okay, and there it goes, assembling the group transaction. And once this goes out, then you'll see that transaction complete. And that's how that is done. So getting into PYTEAL. PYTEAL is a library that you can use, and there's the URL up at the top. But basically, here is the definition in Python of a TEAL application that you want to write. And now we can go ahead and compile that into byte mode, and this TEAL source is what is generated. So you can actually see the TEAL code on the right. It looks similar to what we saw in that example with Algorand. And so that's it. You got the Python, and it makes TEAL. Now let's talk a little bit about creating a new application. So if you were using PYTEAL, once again, you'd run that through the compile TEAL method that would generate your source code. And then you would see here, you've got the ability then to compile this programmatically into bytecode, which will be your approval program. And the approval program, then you would pass in as a parameter to, for example, creating the application. So this is this first step in the life cycle of a stateful contract. And then what about debugging? So there is a debugger you can use to wrap together information about accounts, signed transactions, and approval programs. All 3 of these get bound into what's referred to as a dry run request. The dry run request then is used with the TEAL debugger, which has all the information, once again, about the accounts, the transactions, and the approval program that you would need to do the debugging. And this is what it would look like. You go to Chrome Inspect, and you can step through each line of the teal, and then you can expand out your scope for local and global variables that you might be having on the stack. And it's pretty straightforward after that. Let's take a look at the Stateful smart contract lifecycle here. All right, let me give you the lay of the land in this program before I hit run. All right, down the bottom is the main routine here, right? We got main, and what we're going to do is, of course, we're going to create our client that we've done like in all the other examples. Then I'm going to call this compile teal method. I'm going to read in a file I've got over here, this hello world teal, what you see right there, which is just a counter, a global counter. We're going to get, and then we're going to put and increment a global counter. Then we're going to update it with this one, which is we're going to add in a local counter to it. That's it. That's the only difference as well. So if you take a look at this code that I've got here and scroll down the main line, first thing we're going to do is compile that teal. Now I've got the byte versions of those, and then we're going to take that approval program and we're going to call a method to create the application. And then we got to opt into the application. We're going to do that for the user, and also the creator. So that'll be called twice. And then we're going to call the app and execute it. And then we can read the state from this application, and then we can update the application using this method in this procedure. I got breakpoints in all the procedures, so you'll see that. And then also call that app once again with the updated version of yours. And then you can close it out and delete it when you're all done. So let's stop this from running. Let's go ahead and pick this one up and go here. So there's our shoe accounts, the creator account, the user account. There's the approval program where we're going to go ahead and read in, or basically this is the PYTEAL that you see right here. So this is going to generate that teal that I just showed you. And then this is the refactored one, which also now has the local in it, right? So that's the Python that's associated with that. And then I've got a clear state. That's a third one, which is just one to go ahead and clear the state. Now, the compile program method that I have here basically will provide a result. This is the source that we generated from up above. And then now it's going to return back the bytes for the array of the smart contract. So now we're hitting the main line. Now we're going to go into create that app call. And we'll see what this looks like right now here to create the app. So when you create the app, then it's going to call this method here, application create TXN. So this is going to take that compiled program that we did up above. And also there was a global and local schema defined up above for the number of variables that you would have both on the global for numeric and byte arrays, as well as for local for numeric and byte arrays. And that's what you'll be seeing displayed on the output down below. So I'm going to go ahead and run this. We're going to create the transaction, or excuse me, create the application. And the application ID should print off down below in the debug window right there at the very bottom of the screen, right there. Copy that off. Now we'll use that application ID on all of these calls. And so the first one is going to be to opt in. So this is the actual method call now. And then the second one is going to be called to opt in for the creator. All right, we did one for user, one for creator. And then we want to continue on to actually calling the application. And there it is. So now we're going to call the app. And you can see that I've got the hello world teal is the one that I'm using. And then when that gets into the method call, I'm going to use this no op call to actually call it. And then you can do things like debugging, right? You have a file teal, you get the ability to create a standard DRR file as part of that process. So the dry run, like we referred to. And then let's go ahead and send the transaction. And then now what we'll see is we're good to go to do the update. And here you can see some of the values coming out. So we've got a couple fields. One of them is a counter that keeps getting updated. That's this unit. And then afterwards, when we go ahead and do the update on the next one, that's when you would see the process for that one down below with the local counters as well. All right, information. You can actually use this. Our reference docs have a run in Postman if you want to do REST API calls. Just hit that, boom, you're up in the Postman environment. Also, we have the newsletter, like we talked about. Community projects is a great community page under developer.algorand.org/community. And then we have a great product called Reach, actually. Reach is a product that facilitates multi-blockchain backends and multi-language front ends is the easiest way I could describe it. For example, you can write an application in JavaScript and compile it out to Ethereum, change one setting switch, and then compile it out to Algorand. And then also, they've just introduced a remote compiler, and it now supports Python as well. This is like hot off the presses. So I would look into Reach if I were y'all and take a look at that. They got a great step-by-step tutorial to follow, but that's certainly another alternative to building applications. And then this is the algo signer that I had showed you initially. There is an API for that you can integrate into your applications. And then similarly, MyAlgo works without a plugin, and that's another way to manage your keys. And AlgoDia we showed you too up front, a really great tool. There are some reward programs to make you aware of by the foundation, and the foundation is a separate company. Algorand Foundation is responsible for token economics. Ryan and I both work for Algorand Inc., and that is technology focused. And the developer rewards are all done through the foundation. But take a look at some of the grant programs that we got. You can submit a grant, you got a great idea. You can see some of the recipients out there as well. So really some great resources there. Lots of ambassadors. I think we're closing in on 600 now in over 60 countries around the globe. So contact Stephen at Algorand Foundation. These are like our MVPs out there in the industry. So a lot of them are creating content for the developer portal. And actually, if you just log into our developer portal, that's all you need to do to become an author. You can go ahead and start submitting articles. Great resources on Teal and Proof of Stake. Again, the links are in the deck, as well as where the code samples are. We got them all out there in a few different locations. We do have a developer office hours every other Tuesday. Also, if you go out to this site, you have videos of all the prior sessions that we've done. And also we have this Discord channel. I encourage you all to join that. I'm gonna keep it on there for a second. As well as I just want to point out a few more resources I have in the deck. That Minter I showed you, NFT game solution. You've got the Unity solution for you game developers out there as well. And then also we've got VS Code tutorials. There's one out there for Python. How to, if you haven't used VS Code yet and you want to start debugging some Algorand applications, that's what that does. And then we'll playground a lot of these great tools. So in summary, we covered a lot of ground here. We went over blockchain use cases to kind of give you a feel for all the different vertical industries that really have applications that are good for blockchain use. A few of those that we mentioned were supply chain use cases, as well as DeFi is huge. Now NFTs, assets, tokens, anything that requires that sort of capability. Then we looked at some of the basics of blockchain, and we went over the pure proof of stake protocol. And when we looked at layer one features, we're talking about assets, talked about smart contracts, both stateful and stateless. We talked about atomic transactions and ability to do rekeying. And finally, we took an in-depth look at the Python SDK, lots of code we walked through, lots of tools, development tools as well, to make your lives easier going forward and building these solutions.